Okay, exactly. Skanda could explain every component of QPSK transmitter without leaving a single point. Very good. I'm very happy with that. Yes, I expect even other students should also involve with the same spirit. Okay. So I expect other student to just say about QPSK receiver in the same line how Skanda could explain. Na? Yes, come on. Yes, my dear students, open up your mouth. Let me spend 2 minutes and I would like to hear from your mouth only whatever I've discussed in the last class. Then I will take up from that point. Yes, be fast. Huh? Please try to understand. So, yes, I'm asking to explain, means just to summarize what QPSK receiver, how does it works? What is this, sir? After learning BPSK, what is the difference? You should be able to identify and you should be able to, okay, can I say if I club two BPSK, right, receivers, can I call that as an QPSK receiver? Just think what is there? See, received signal x of t, right? I said which is equal to the transmitted signal plus noise will be passed through what? Correlators, right? So I will be using two correlators, right? So two correlators. For those two correlators, the basis function is what? One is pi 1 of t, which is equal to root of 2 by t cosine of 2 pi fct. That is one upper correlator. And lower correlator is what? That is pi 2 of t, which is equal to square root of 2 by t sine 2 pi fct. Right? Then, after multiplying, it will be integrated. So that together we call it as a correlator. Then output of correlator is what? The observation vector. I represented that as x1, x2 will be passed through a decision device. See, that block is not changed. Only I am using two correlators and two decision device, right? Then output of those decision devices will be given to the multiplexer. Then output of multiplexer will be the estimation of the transmitted symbol, I said. Okay. So that is how the QPSK receiver works. Means what I wanted to say here is if you understand one particular concept, it becomes easy for you to understand further topics, right? If you are very clear about BPSK, I don't think you will be finding difficulty in understanding QPSK. Yes or no? Yes, my dear students, respond. Response is very much required. Otherwise, what? I will be keep talking and you will be just listening. Even I said from my side how QPSK receiver works and how it is related to BPSK. Right. Even after saying that, nobody says yes or no. Yes, even now, even after saying this, also nobody says, what is this, sir? And what sort of motivation I can have? Hmm? If you people don't respond, yes, why you?
Yes, sir.
Yes, thank you, Namita. Very few people are active, what I feel, what I understand. What unmuting and talking to me is a difficult task, just to say yes or no. Hmm? Yes, hope you are able to see the PPT, right?
Yes, sir.
Sir.
Yeah. So just I will take 2 minutes, though I have revised. One of your friend has explained about QPSK and I told about receiver. Just once again, I wanted to say, okay, to all of you. At least after this, I expect other people to respond. Okay, as we have discussed that the binary data sequence will be passed through the polar NRZ encoder. So the purpose is I am going to represent here binary symbol 1 by a positive pulse and binary symbol 0 by a negative pulse, right? Then I said it is a demultiplexer, right? So what this demultiplexer will do, it will segregate that given input binary sequence into odd and even sequence. Okay, so it is nothing but serial to parallel converter only. So I get the odd sequence on the upper side and even sequence in the lower side. That is why it is written A1 of t and A2 of t. This is multiplied by the basis function, which is nothing but carrier, right? So which is equal to root of 2 by t cos 2 pi fct. And this even sequence is multiplied by another basis function, which is equal to what? Root of 2 by t sine of 2 pi fct. Means here the carrier frequencies, right? One is pi 1 of t, another is pi 2 of t. They are 90-degree phase difference. One is cos, another is sine, right? Means this is one BPSK transmitter, what I can say. This is another BPSK transmitter, right? Then I am summing up those two and I am saying it is a QPSK signal, right? So with respect to BPSK, if you understand, only this demultiplexer will not be there. Okay, rest of the blocks are same. Binary data sequence will be there, polar NRZ level encoder will be there, because there I am using only this one, so I don't require demultiplexer. Here I am going to use two basis functions. Means I am going to have two carrier frequencies. They are in phase difference of 90-degree, right? So that is why I am going to split the incoming data into odd and even sequence. Then I am modulating that odd sequence and as well as even sequence by multiplying these carrier signals. Then I am summing up to get the QPSK signal. Fine. Then I said the received signal, which is x of t, which is equal to what? S of t plus noise. That will be given to the two correlators. So I am using two correlators which are connected in parallel, right? So this is one correlator, this is another correlator. So whatever the carrier frequency I am using at the transmitter side, same carrier frequency I need to be used at the receiver side also. Then only I can say it is a coherent receiver, right? So that is why I am using in the upper path, that is the carrier frequency as pi 1 of t, the basis function, and for lower path I am using pi 2 of t, right? So this much is same only, right? Correlator followed by a decision device. Even in the BPSK also same thing was there, correlator decision device, correlator decision device, right? So the upper one I call it as an in-phase component because it is multiplied by cos, right? And lower path I am calling it as a quadrature component because here the basis function is sine. Okay, so you all know how, when do we say it is in phase and quadrature component for the given signal. Then the threshold is also equal to 0 only, threshold value, right? So the output of the decision devices, right, here I will get x1 and here x2 will be multiplexed. Means it is what? Parallel to serial converter, right? Because my input data is in series, right? So I will be getting that. So I will be estimating what is the transmitted binary sequence. So this is in brief about QPSK transmitter and coherent QPSK receiver. Just try to understand this. It is not different from BPSK, and how it is similar to BPSK, what is changed in QPSK set, right? So let us try to understand the waveforms of QPSK. Okay, so I think I was with this, I told, but still I would like to repeat once again about how we get these waveforms. Okay. Yes, able to see the waveforms?
Yes, sir.
Yes, sir.
Yeah. So please please be attentive. Okay, it is very, very important to understand these waveforms. So this is my input binary sequence. Okay, 0, 1, 1, 0, 1, 0, 0. Okay, so this is my 8-bit input, 8-bit binary sequence. Okay, so 2 bits I call it as a die bit, right? So 0, 1, 1, 0, 1, 0, then 0, 0. I call that as a die bit. Die means 2, right? So die bit. Fine. So what I am doing, I am separating this 8-bit data into what I said, odd and even, right? If you write here 1, 2, 3, 4, 5, 6, 7, 8, you take the bits of what 1, 3, 5, 7. So this is 1, right? So this is 0, then 1, then again 1, 0. So this will be the odd sequence, right? Similarly, even sequence will be what? 1, then 0, then 0, then 0. So that is the even sequence, right? So just it is one BPSK modulation only. Whatever written here. So SI1 into pi 1 of t is nothing but this is one BPSK signal, and this is another BPSK signal, right? So here y means here that odd sequence will be multiplied by pi 1 of t. What is that pi 1 of t? It is a cosine signal, right? So because here 0 is there, so it is multiplied by minus cos, right? So that is why minus cosine signal is written here. Okay, so it is written for 2 cycles because uh, here I have segregated, right, odd and even, so it will be occupying 2 cycles. Is this clear? So first 0 is there, that is why it is minus cosine function or minus cosine waveform. So and which is written for 2 cycles. So it starts with minus cos and ends with minus cos. Is that fine? I'm asking.
Yes,
Yes,
sir.
it's clear. Yeah. Okay. Next is what 1 is there, right? So 1 I transmit with plus cosine waveform, right? That is why here it is written plus cos. Okay, plus cos. Hope you are able to follow my cursor. Then again, next one bit is there. Again, one more cosine function, right? One more cosine wave of 2 cycles till this. Next 0 is there, so it is minus cos. So minus cos waveform is written. Okay. Similarly, for even number sequence, which is multiplied by what? Pi 2 of t, which is what? Root of 2 by t sine 2 pi of ct, right? So for sine, uh, here see, bit 1 is there, right? So this will be transmitted by sine signal, right? With 0 degree phase shift. So that is why it is written sinusoidal signal, okay, of 2 cycles. The next is 0 is there. So that is minus sign. That is why 180 degree phase shift waveform is written for 2 cycles. Okay, and again next bit is 0. So one more sinusoidal waveform is written for 2 cycles. Then one more 0 is there. So one more sinusoidal waveform, okay, of 2 cycles. Hope this point is clear. So 1 0 0 only for one bit. I will start with 0 degrees sine waveform. Then 0 is there. So that is why I'm writing with 180 degree phase shift sinusoidal signal. Okay. Yes, my dear students, is this clear? These 2 points, odd number sequence and even number sequence, is it clear? I'm asking.
Yes, sir.
Okay. So I hope it is clear, right? Then what I said, we are adding these 2 waveforms. Okay, if I club these 2 waveforms, means if I sum these 2 sequences or these 2 waveforms, I will be getting the QPSK waveform. Okay, so what I said for 0, 1, right? 0, 1 will be in which quadrant? This is 0, 1. So I'm going from right to left. Yes, I expect you to tell what is the phase shift for this 0, 1.
3 pi by 4.
0, 1. Just think. This is what the confusion many people have. First, I say I am reading odd, then even. You want me to go back and say about that signal constellation diagram? I will, 1 minute, I will go back there and I will just say, yeah. I wanted to make clear about because many people will will not understand this because they will be confused because with 1 1 and 0 0 no issue whether you read from right to left or left to right, it is same, right? But this 1 0 and 0 1 is the problem. Okay, many will go wrong here only. So I read here 1 0 means what? From right to left I am reading, right? So if it is 1 0, 1 is odd sequence, I say 0 is even. Okay, 1 0 means it is 135 degree, that is how much it is? 3 pi by 4, right? If it is 1 0. So if it is 0 1, 0 1 means it is 7 pi by 4. Okay, that is how much? 315 degree. Hope this point is clear. Yes, my dear students.
Yes, sir.
Yeah, please keep this in mind. This is only one change. Okay, I am reading this as 1 0. 1 0 means the phase shift will be what? 135 degree. That is 3 pi by 4. This is what? 0, 1. Okay, 0, 1 means the phase shift will be 7 pi by 4, which is 315 degree. So with this clarity, so there is no doubt in this 1, 1 and 0, 0, because 1, 1 will be whether you read from right to left or left to right. So it is 45 degree, right? For 0, 0 also, it is pi by 4, which is nothing but 225 degree, right? You have to be very careful with this 1, 0 and 0, 1. So 1, 0 means the phase shift is 135 degree, which is nothing but 3 pi by 4, and 0, 1 means the phase shift is 7 pi by 4, okay, which is nothing but 315 degree. Hope clear? Hello?
Yes, sir.
Yeah. So with that clarity, so let me just take up and finish this S of t waveform. Okay. So here, see, it is 0, 1, right? So 0, 1 means the phase shift will be what? It is 7 pi by 4. Right? 7 pi by 4 means it is 315 degree, right? So the phase, so it is 315 degree. It starts from 315 degree and ends with 315 degree. Hope this point is clear. In a given sinusoidal waveform, you should know where 0 degree is, where 90, where 45, where 135, where is 225, and where is 315. I hope you are aware of that, right? Yes, my dear students, the first for die bit, that is for 0, 1, what I am saying 0, 1, for that, what is the phase shift I am supposed to write? The phase of the Qpsk signal starts from what? 7 pi by 4, and it will be ending to 7 pi by 4. That is for 2 cycles. Could you grasp this? See, this is sinusoidal signal. No? This will be a 90 degree point, right? This point is 45, and this point is 135, and this will be 225, and this will be 315, right? So that is why it started from 315. So it is started with 315 and 2 cycles, right? So that is why it is ending with 315 degree or 7 pi by 4. Yes, is this clear? 0, 1, 0, 1 is 7 pi by 4. Next one is what? 1, 0. So 1, 0 means what? Yes, 1, 0. Exactly reverse, right? That is 135, right? 1, 0. So that is why it started with
Yes, sir.
135. Okay, 135 started with 135. See, now I have two symbols of 1, 0, 1, 0. So I have to write 4 cycles, right? So that is why 4 cycles is written. So it started with 135. Okay, 2 cycles is ending here. Then again it starts with it will be ending here. Again it will start with one more 2 cycles for another 2 bits. So that is why I am writing 4 cycles. Hope it is clear up to 135. So starting with 135 and ending with 135 because I have 2, 1, 0, 1, 0. Okay, the last one is what? 0, 0. So 0, 0 means it is 5 pi by 4, right? So 5 pi by 4 means it is 225 degree. So starting phase is 225 degree. So I have to write 2 cycles and it will be ending with 225 degree. Yes, any questions to ask in this? You can ask. Be clear about this because it is one of the important modulation technique. What I can say, many people will find it difficult to understand this waveform, especially Qpsk waveform. Okay, so I hope I tried my level best to give better clarity and understanding about this. Still, if you have any questions, you can ask. If you want to repeat, if you want me to repeat, I will repeat. Otherwise, I will ask some of the students to say what is the uh, phase of the Qpsk waveform for so and so combinations. Yes, you want me to repeat? Hello?
No, sir.
No. Bharti, na? Is it Bharti? I don't know. I don't know whether my
No.
PPT was visible or not. Ananda?
Yes, sir.
Yeah, understood, man. Yesterday you were asking something, right? You were saying it is not visible. Today, is it clear?
Yes, sir.
Okay. Okay. So randomly, I want any one of you people to just reproduce what I said about the waveforms. Maybe I wanted to hear from those who have not interacted so far from them. Obviously, those who are interacting regularly, they can also interact, but let other people also open up their mouth. Yes, quickly without wasting time, because yes, my dear students, come forward, try to uh, reproduce your understanding about this waveform. Hello.
Yes, sir.
Yeah, Akshay, you wanted to explain?
Yes, sir.
Yeah, please.
Given we
Is it
have,
visible? Yeah, is it full slide now?
yes, sir.
Yeah, please, man.
Given we have an binary sequence, which is given in debit form, like two binary digits in one set. So we
Uh,
have four such debits: 0, 1, 1, 0, 1, 0, and 0, 0 is the given binary sequence of data. So we
very
have to segregate it as odd numbered and even numbered sequence. Uh, the indexing 0, 1, 3, and 5 goes as odd numbered sequence. 2, 4, 6, 8. Uh, sorry.
Yeah, you can start with
Yeah.
1, 2, 3, 1 to 8. Then
Yes.
in that 1, 3,
1,
5, 7 will be
1,
odd.
3, 3, 7 is odd numbered sequence. 2, 4, 6, 8 are even numbered binary data. So initially we take odd numbered sequence and multiply it with cos signal so that we have a coherent.
Means we get one BPSK signal. It is nothing but one BPSK signal, right? Odd numbered sequence.
Yes, sir.
Uh,
So that we get the in phase qua- uh, in phase component.
okay.
And then since we are multiplying the initial of cos with 0, we get negative of cos signal, and then for 2 cycle it continues, and then again the term changes to 1, so that the polarity also changes. The cos will start from positive end and then continue for 2 cycles. uh, uh, Therefore we create a one complete signal with odd sequence. Same goes for even sequence. We are multiplying the binary data with sine signal. Since the first term is 1, we don't have any negative term. We don't start with a negative term for this waveform. And then for the final waveform Si of t, we have to consider the debates. 0, 1 refers to nothing but combination of even and odd bit groups. So 0, 1 infers to the phase 3 pi by 4, which is nothing but 135 degrees. It
No, no.
starts.
Actually, I think 0, 1, I said, no, this is odd and this is even, right? So 0, 1 will be not 135, it will be 315 degree. That is why I went back to that signal constellation diagram and I explained how I read. I read from right to left.
Yeah, sir, right to left. Okay.
So 0, 1 is nothing but 7 pi by 4.
7 pi
And
by 4.
315 degree. That is why it started with 315 degree. Okay, it is not 135. Right?
Yes, sir.
Ah,
Uh, the phase starts at 315 degrees and continues for 2 cycle, ends there.
ah.
And then again we have 1 and 0 for two continuous cycles. which is nothing but 3 pi by 4. It is
Yeah,
same as 135 degrees.
very good.
So the cycle starts at phase 135 degrees and continues for two cycles.
Yeah,
And at last we have 0, 0, which is
uh,
nothing but 5 pi by 4, 225 degrees.
yeah. Very good, man. Very good. You tried your level best. Thank you. So similarly, I would like to hear from one more candidate. Yes, whoever is interacting, I can make difference. So please don't be idle. So I am not conducting quiz. So rather than conducting quiz, I am asking. I am doing this question and answer. So people throughout my class, each I wanted to interact. Hope you all understand what I am asking. Yes, be fast. Hello. There's a lot of motivation only is not there. Hmm? Why it is happening? Why people are not coming forward to share their understanding? Nothing wrong, no. I am there to correct. Right? Don't hesitate. See, Akshay Kumar has started explaining so nicely. So it will improve your understanding also. Yes, I expect voluntarily to take up this and take 1 or 2 minutes to say in your own words, how do we get this QPSK waveform? Yes, my dear students, come forward. Okay, I will mark as per my attendance. I will call. I think now let me find out who is very inactive so far. Okay, not opened his mouth only. Yes, Manoj, can you try, man? Manoj. Yes, Manoj. Manoj. ಚುಡುಕಿನ Yes, I'm asking Manoj. No, Manoj, he's not talking. Okay. What about Rohit Joshi? Yes, Rohit Joshi. What is this, sir? I will not consider your attendance, man. Okay. Rohit Joshi is not talking. Manoj is also not talking. What about Manjunath? Manjunath?
Sir.
Yeah. I'm asking, can you just uh, interpret your understanding about this QPSK waveform in just
Yes,
one
sir.
minute? Uh,
Yes, sir.
yeah,
Sir,
please.
that the input binary sequence that is already it will be given, sir.
Yeah.
So from that we have to segregate even and odd bits.
Okay.
So in the odd bit, it is represented by it is I mean graphically it is represented by cosine, sir.
Very good.
And 0 is taken as negative, and
Okay.
1 is taken
What
as
is minus
positive.
cos? You have to say minus cos. 0 minus
Yeah.
cos. 1
Yes,
by
sir.
plus cos. Yeah.
And whereas in the even sequence, we are
Yeah.
taking it is in the sine wave,
Yeah.
and 1 is represented by plus sign, and 0 is represented by minus sign.
Very good.
Similarly,
Yeah. Very good.
and the S of t has been represented by the uh, it has been represented from the uh, uh, like there is a formula, sir. 2 minus I by
Yeah.
4,
No, no, that
where I
formula is
is,
fine. See, what I'm saying, I'm adding these two waveforms, odd and even.
yes,
Right?
sir. We are adding it, and uh, like you showed a graph, no, sir, in the previous slide. Can you open
Yeah,
that?
fine. But now you need to tell with respect to the die bit, what is the phase? See, for the first die bit is what 0, 1, right?
It's a 7 pi by 4, sir. It
Ah,
is
so for
7
that,
pi by.
yeah, for that the QPSK waveform starts with 7 pi by 4 and ends with 7 pi by 4. So
Yes, sir.
next one is what? Next is 1 0. Right, for 1 0, what is the phase shift?
Uh, I I can't remember, sir. It's in the previous slide, but
Ah, okay,
I
but we
I don't
should
remember.
be, it should be. Okay, for 1 0, it will be 3 pi by 4. Okay, 3 pi by 4 is nothing but 135 degree. So it starts with 135 and ends with 135. Next
Yes,
diamond is also 1 0. That is why it continues with 135 and
same.
ends with
Yes,
135. Right? So the last diamond is 0 0. So for 0 0, the phase shift will be what? It starts from uh, 5 pi by 4 and ends with 5 pi by 4.
yes,
Okay.
sir.
So 5 pi by 4 is nothing but how much degree? How many degrees it is? 5 pi by
Uh, i-
4.
is it 2 to 5, sir?
Yeah, 2 to 5 degree, right? So it
225.
starts with 2 to 5 and ends with 2 to 5. Very good, man. Very good effort. Yeah. Uh, yes, similarly, let me take another 1 minute. What about Bhargav? Bhargav. Sorry. Okay. Not ready to unmute and talk. Pooja? Pooja also no. What about Sovik? Yes, Sovik Rai.
Yes, sir.
Yeah, can you just interpret your understanding of QPSK waveform quickly? Yes, Sovik, be fast. Can you? Sovik? Yes, Sovik, I'm asking. Hmm. So now I understand how many are active, giving importance to my class, and they are able to understand. Hmm? Mm. Yes, Sovik, you cannot? Yes, what about Ramya?
Yes, sir.
Yeah, can you interpret your understanding, ma?
Yes, sir. Yes, sir.
Yeah, please.
Uh, we'll be given the binary data.
Yeah,
From the given binary data, we have to consider the even and odd bits. So here, 8 bits are given. We have to consider 1, 3, 7, 5 as the odd bits and 2, 4, 6, 8 as the even bits. So once we do that, we have to draw the waveform. For
okay.
the odd numbered sequence, we consider cos.
Yeah,
So for the bit 0, we consider it as a minus cos, and for 1 plus cos.
okay.
And similarly for even numbered sequence, we consider sign, and for 1 it is plus sign, and for 0 it is minus sign.
Very good.
So once we get the odd and even numbered sequence, we have to add it to get
Yeah.
the QPSK waveform according to the signal constellation diagram.
Yeah, can you just tell me for the first die bit? Okay, what is the phase of the QPSK for 0 1?
It's 7 pi by 4, sir.
Yeah,
350.
so yeah, it starts with 7 pi by 4, ends with 7 pi by 4. So it is for 2 cycles, right? So what about
Yes.
next one? Next one is
Uh,
1 0.
1 0 is 3 pi by 4, sir.
Yeah, so it starts with 3 pi by 4 and ends with 3 pi by 4. Right, again, one more 1 0 is there. That is why it is continued for another 2 cycles, right?
Yes,
So
sir.
it is
Yes.
ending with 135. So last one is what?
0 0 is 5 pi by 4, sir.
Yeah, 5 pi by 4 means which is nothing but 225 degrees. So it starts with 225 degree and ends with 225 degree. Fine?
Yes. Yes.
Okay, thank you.
Yes.
Thank you for your. Yeah, so just let me take another example. Okay, I think you take 2 minutes time. I will ask again from my side some of the students. Now I have taken a different data. Hope the data is visible. Yes, is it visible? See, I am saying the binary data is what? 11 1 0 0 Okay, 11 1 0 0 So I am segregating this into what odd and even. It's very clearly written here, and even the odd sequence is written and even sequence is written. Right, that is in phase component, quarter phase component. Then the QPSK waveform is written. So take 2 minutes. I will ask some students, they should answer to understand this. Is that fine?
Yes, sir.
Okay. Yeah, can I expect answer? Yes, Rohit Joshi.
Yes, sir.
Yeah, can you interpret this result, man? This is what the QPSK waveform has shown here. At least you are talking now. It is good. Yeah, be fast, man. Yes, what happened, Rohit? Rohit,
Yes, sir.
can you interpret the result?
Sir, I am not getting, sir.
You are not getting. Means you are not attentive so far. What is the difficulty, man? Can you tell me what is the difficulty? Why you are not getting? See, I explained twice. Yesterday also I explained. Today also I explained. Then I think two of your students, two of your friends have explained. Two or not two, three people have explained from your end. Still you are saying you don't know. Is it possible to say what made you not to give attention for this concept understanding? Rohit? Yes, Rohit. Are you with me?
Yes, sir.
Yeah. Are you attentive? Are you really
I,
listening my lecture?
yes, sir. But I don't understand, sir, how to interpret this result, sir. Final result.
Okay. See, okay, at least now you listen carefully. I will again explain, and after explaining, I expect you to answer. Is that fine?
Yes, sir.
Yeah. So listen carefully. What I said is, so this is the given input binary sequence. Okay, 11 1 0 0 1 1 0. So what I do here, I separate with the given 8-bit binary data into even and odd sequence. So I hope you understand what is odd sequence and what is even sequence in this. You number it just 1 to 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay. In that, what is odd? Odd is 1, 3, 5, 7. So I'm taking 1, right, as a first bit. Then third bit is what? 0. Then fifth bit is also 0, right? Then seventh bit is 1. So that is my odd sequence. 1 0 0 1, right? Similarly, the even sequence is what? 1, then 0 1 0. That is my even sequence. So what is there in the QPSK transmitter block diagram? I am modulating the odd sequence by cosine wave. Okay, means I am multiplying the odd sequence by cosine signal. That is why I get this signal. Means that is one BPSK waveform, right? So one will be represented or transmitted by cosine wave plus cos, and 0 will be minus cos. Okay, that is why for first one is written plus cosine wave, and for 0 minus cosine wave, and here two zeros are there, that is why it is written 4 cycles of cosine wave, negative cosine wave, right? Then next one is there, so I have written positive cosine wave of 2 cycles. Is this clear?
Yes, sir.
Yeah, I transmit 1 by cos and 0 by minus cos. That is what in simple words. Similarly, the even sequence, right? I multiply that even sequence by a basis function of sine 2 pi fct. So that is why, so 1 I transmit with sine plus sine, and 0 I transmit with minus sine. So that is why I am writing for 0 the 180 degree phase shift sine wave, right? Again, next 1 is there, sine wave, then next 0 is there, minus sine wave. So I hope you have understood this in phase signal and quadrature phase signal with respect to the transmitter side. So what I said, both these things will be added and it will be transmitted as a QPSK waveform, right? So I said, so for this 1-1, okay, 1-1, the phase of the QPSK signal is what? It is? Yes, is it possible to say from your end, Rohit?
Yes,
For
sir.
1-1.
For sequence, it's a cosine, and sir, for even sequence, it's a sine, sir.
Fine, man. With respect to the signal constellation diagram, I wrote two basis functions, right? Pi 1 and pi 2. So 4 quadrants are there. First quadrant will be 1, 1. Next one is what I said. Then what is third quadrant? It is 0, 0. Then fourth quadrant. Okay. So accordingly, can you tell 1, 1 will come in first quadrant? So what is the phase shift I said for 1, 1? So it is 45 degree. Okay. So it starts with 45 degree and ends with 45 degree. Okay, that is why for the die bit 1, 1, the phase of the QPSK waveform I represent with 45 degree. Okay, so next one is 0, 0. So for this 0, 0, the phase shift will be 225 degree, that is 5 pi by 4. So that is why it starts with 225 degree. Okay, and ends with 225 degree. Next one is what? 0, 1. So 0, 1, for 0, 1, the phase shift will be 7 pi by 4. That is 315 degree. So that is why it starts with 315 degree and ends with 315 degree. Okay, I hope you will understand this 315 degree, right? The next one is what? 1, 0. For 1, 0, okay, the phase shift will be what? 135 degree, which is nothing but 3 pi by 4. So that is why it starts with 135 degree and ends with 135 degree. So clear it is. I think, I hope all should be able to write without any mistake about the QPSK waveform. Okay. Yes, ma'am. Now it is your time to interpret this waveform. I will give 1 minute time. Rohit.
Yeah.
Yeah.
So, like you have explained, the first wave is of odd sequence. So 1, 0, 0, 1 should be there. 1 represent 3 and 5 and 7 respectively. The second wave is of even wave, and the odd sequence, the first wave in which 1 represent the cosine and 0 represent the minus of cos. Similarly, in case of even wave, the sine 2 pi fct, so we'll use 1 for positive sign and 0 for negative sign. Now for 1, 1, the 45 degree should be there in a quadrant form, and 0, 0, the 225 degree is there. For 0, 1, 315 is there, and for 1, 0, it's 135 degree is there. So in this way, the whole signal will form. So.
Okay. So to put it in a slightly better way, what I can say is the die bit 1, 1 will be conveyed or transmitted with what phase? With 45 degree phase. Okay, with 45 degree phase of the carrier, the die bit 1, 1 is transmitted. Okay, 0, 0 is conveyed, okay, with the phase of what? 225 degree. Okay, and 0, 1 will be conveyed with what phase shift? With 315 degree, that is 7 pi by 4. And 1, 0 will be conveyed with a phase shift of 135 degree. It is nothing but 3 pi by 4. Okay. So this die bit, okay, and means 4 die bits I have, right? 1, 1, 0, 1, or I can say 1, 0, then 0, 0, then 0, 1, right? So these 4 die bits will be converted with 4 phases, right? 1, 1 I said 45, Then 10 I said 135. Then 00 I said it is 225, and 01 will be with 315 degree. Okay, so these are the 4 different phases I used to convey these 4 dibits. Okay, so I hope I conveyed what is QPSK with the 2 examples of waveforms. Hope you have understood. Okay, so with that positivity in my mind, and let me I think just say about this. I think I said this. Okay, the efficiency, bandwidth efficiency of QPSK will be what? 2 bits per second per hertz when compared to BPSK. In case of BPSK, I will be transmitting only 1 bit per second per hertz. Okay, and I think in the next class, let me, yeah, hope I shown this yesterday also, right? So you can just have a look once again. So 00, I said what phase, carrier phase, it will be 225 degree, right? For 10, it will be what? It is 135 degree, right? For 01, okay, it will be 315 degree, and for 11, it will be 45 degree. Okay, so I read this symbol transmitted from right to left. Okay, so be careful with this 01, that is 10 and 01. Okay, majority of the students do mistake in this only. Okay, is that fine? So let me take up in the next class about finding the average probability of symbol error. So we have done with respect to BPSK. In the same way, let us try to derive the expression for average probability of symbol error. Is that fine?
Yes, sir.